Hi, in this video, I just wanted to summarize what we studied in control systems and try to draw everything to a close. Now, there is a lot more to learn in control systems, and we have just done a snapshot of it. But I think uh, what we have done kind of gives you the basic idea of control system theory and how people start to develop these systems. Okay, so let's try to bring everything to a close. So let's say we have a process, right? And this process could be anything. We have taken examples of a boat. We have taken examples of uh, automobiles, our human body, or whatever that process is. Okay, and the process gives you an output when it responds to an input. But what you want to do, or what we want to do, is we want to control the output, and we want a certain output. Uh, uh, let's just simplify and say we want a constant output, okay? Uh, and to do that, in the presence of disturbances, in the presence of uh, probably noise, and in the in the presence of changes in the parameters, right? What we can do is we can have a feedback which kind of takes the input, compares it, let's say, with the output, right, and gives an error signal to the process so that the output is maintained at the value that we want it to be maintained at. Now, we can get the we can control the system in this way, right? But we may not be able to get the kind of performance characteristics that we want. So, for example, you may not be able to get the rise time that you want, the speed of response that you want, or you may not be able to get the steady state error that you want just by doing this. So, in many systems, what we do is, in addition to the feedback, we also put what is called a controller on the system. Okay, so let's call this a controller. Let me write it as GCS. Okay, but so once you put the controller, there are two things that you want, right? One, you want to know whether putting that controller is going to help you to achieve the performance that you desire. So that's one. And another thing that you want to know is whether this control system is actually going to behave itself. Is it going to become unstable, which we saw was one of the disadvantages of feedback control systems, right? When you introduce this feedback loop, you, along with this feedback, you introduce the possibility of instability, and you want to test that, right? So two things: you want to control for the performance, you want to see whether you have got appropriate performance measures, and also you want to make sure that your system is stable. And we've done the tools, we've looked at the tools for doing these things, right? We have seen how we can evaluate the stability of the system. We have seen how we can, at least in the time domain, we can specify some performance measures uh, and design our system towards that. Now, what we haven't done in control systems is, so what we've said is, if we have a controller, we know probably how to evaluate the performance, we know how to evaluate the stability. But how do we get to the controller in the first place? We have not really covered that aspect of control theory. So there's a lot of theory that goes into how do we select these controllers, okay? And if there are some parameters in the controllers, how do we select those parameters, okay? So just as a very broad overview, the most general thing to do with controllers is you can have what is called a proportional term in the controller, where your controller transfer function is just a proportion, is just a constant, okay? So that's called a proportional controller. You can have a derivative controller where your uh, where your uh, controller is basically a derivative term, that is its s, and maybe there may be a constant, let's write it as kd for derivative. And then you can have an integral controller where you have the controller as ki over s. Okay, and let me write this as kp. So that's a proportional controller. So let me also write the name proportional. Then you have the derivative, and then you have the integral controllers. And then you can have combinations of these. So you can have a PD controller which has a transfer function which has a proportional term and a derivative term, right? So it's a proportional derivative controller. Or uh, in its most general, you can have a PID controller, and I'm not sure, it's quite popular. PID controllers, maybe you've heard of this name, proportional integral derivative controller, which has got all these three terms in it. So you have KP plus KDS plus KI, sorry, uh, plus KI over S. Okay, so the basic idea is that you can have these controllers, and there is a situations in which you may want to use an integral term, and there are situations when you want to be using a derivative term, and when you want to have both the derivative and the integral term. And then there are methods by which you can calculate these constants kp, kd, and ki, so that you achieve some sort of performance or achieve stability and things of that kind. But we are not getting into that. But I just wanted to kind of draw a summary of the control system. So what are we trying to do? We are trying to control the output of this process, and to control the output of the process we put a feedback, but the feedback may not give us the necessary performance characteristics. It may not give us a stable system, and we can get a stable system, we can get the necessary performance characteristics by adding a controller, or sometimes by adding your sensor also may have a what should I say, a transfer function, right? It may not be that your sensor has a transfer function of 1. So using both these mechanisms, you can control the performance and the stability of control systems. Okay, hopefully that kind of brings what we have done to a close, and we can look at a few problems that give you a little bit more idea of how control systems function. Great.